Alright, so I want to go over with you guys the Unit 2 terms, because there's some vocabulary during this unit that you guys are going to need to know to be able to successfully answer some lines of questioning. Okay, things like vector and scalar quantities. So, right away, some of you recognize this guy from the wonderful movie Despicable Me. That's Vector. He talks about what a vector is, and actually I encourage you to click on this link. We'll show you how to get to that in a little bit, but back to why we put him up. Vector is the counterpart to scalar. Okay, so a scalar quantity is a quantity that describes magnitude. It's number alone, so it talks about how much. We're talking about, like, if we're describing a person's height, they're 6'2". That's how tall they are. A mass of an object, things like that. Also, things that we could talk about as scalar quantities will be distance and speed. Now we're going to get into those a little bit more in just a second. Okay. Now the other thing that I want you guys to know about is vector. Okay, and again, I encourage you to click on this link. You'll never forget it. Vector is a quantity that describes both magnitude and direction. So things like velocity, meters per second. Typically we'll put that as a negative or positive number, negative being to the left on our number line, positive being to the right. Otherwise, it can be in any of the three dimensions. So up, down, north, south, east, west. Okay, vector quantity. Magnitude and direction. Again, these are things like velocity and displacement. Again, we're going to get into that right now. Okay, so position, okay, would be something that talks about where an object is in relation to origin. Okay, so for example, the Taco Bell dog is at -4. That is his position. Okay, that is a vector quantity, given that it is a negative number. Okay, so position would be vector, because not only do we have 4 away from origin, we also have 4 away in the negative direction. Okay, the fuzzy unicorn, +10. Again, saying +10 tells us that it's 10 units away from origin. Okay, again, I would suggest clicking on that. It's fantastic. Fuzzy unicorn, Despicable Me, great movie. Distance versus displacement. Okay, distance is x, or in d, and displacement is how much ground, distance is how much ground that is covered during the motion of the object. Okay, so we're talking about, in your car, you have a odometer. The odometer does not have any idea what direction you're driving. If you're going up, down, left, right, north, south, okay, it doesn't care. All it measures is how many times your wheels turn and how much distance your car covers. Okay. Displacement, on the other hand, is how far out of place an object is. It's change in position. Okay, displacement looks at only where the object starts and where the object ends. And so I'm going to elaborate off of that a little. So like I said, I'm going to elaborate a little bit for you guys. Distance, for example, let's say an object starts at 0. Okay, the object moves down here. So far the distance is 5, and the object turns around and goes back to -10. The distance, okay, would be 5 plus 5, 10, would be 15. Excuse me, 20. Okay, let's call these meters. So the distance, again, the tachometer, or the odometer in your car, would say, well, 5 here, 10, 15, 20. Okay. Displacement, however, delta x, change in position, only cares about where you start, x initial, and where you end, x final. So delta x looks at from where you start to where you end. Delta x is actually -5, -10 meters. Okay, so these are two very different things. Another example real quick. If I'm talking about, so I'm kind of a track guy, we're running around a track. Okay, now your standard distance you'll go around a track is 400 meters. Now people that don't understand track think it's a stupid sport, because if you start, let's say this is a start finish line, okay, and one of the most popular races, one of the most glorified races, is the 400 meter dash. People that don't get it think it's stupid because we start here, okay, go and come back, and I end here. They say, well, why would you even do that? Because your displacement, your delta x, your change in position is 0. you just worked really hard, almost to the point of throwing up. Sometimes you do throw up if you run it right. But you run that far, and technically you don't go anywhere, okay? Those are people that are concerned with displacement. Distance, however, yeah, you ran 400 meters. Your body knows you ran 400 meters. You felt it. You almost threw up because of it. 400 meters, distance, but your displacement is 0, right? Because we start here, we end here, so for that reason your displacement is 0. Your distance, however, is 400, okay? I'm going to go back to this PowerPoint for you guys because we're also going to talk about the difference between speed and velocity. Okay. Now, speed is a scalar quantity again. Speed deals with how fast an object's going and only how fast the object's going. Speed doesn't care about direction. Speed doesn't care about location. Okay. Velocity, on the other hand, is our vector quantity. Velocity talks about the rate at which an object's going and the change in position. Okay. Now, I want to caution you because speed is distance divided by time, whereas velocity is displacement divided by time. Okay, so those two are kind of connected. And here are your equations for this. Okay, now your average distance, or average speed, excuse me, is the distance traveled. So your x, or your d, okay, and speed is x divided by t, the time it takes you to travel. This is the equation I believe that is in your equation sheet. You guys will get this unit. Okay, whereas average velocity, on the other hand, velocity deals with our change in position or our displacement. Okay, so technically speaking, back to this example, okay, if my displacement, let's say I did this in 1 minute, okay, which is a decent 400 meter dash time, my speed for that would be my distance 400 divided by 1 minute, okay, which would be 400 meters per minute. Okay, now we would probably want to convert that to meters per second, but nonetheless, just a quick example. Whereas delta x here, now if we want to know my velocity is delta x over t, or delta t. Okay, and since my delta x is 0, it doesn't matter what my delta t is. This quantity is going to be a velocity of 0 because I haven't gone anywhere. Okay, so back to this. Just wanted to finish this up with you guys. Be very cognizant of the difference between distance and displacement because they tie into the differences between velocity and speed. Okay. Now, I want to encourage you guys. I've already found this video. Okay. I want to encourage you guys to go to the website and check out this PowerPoint that I was going over because, like I said, there are some videos that are attached to this that would be helpful. So it's Unit 2 terms updated, and so again, those videos that I've strongly suggested checking out, they're on here, okay, including some supplemental material on distance and displacement. Like always, thanks for viewing. Email or ask questions when we come to class next time. Over and out.